Hello. For the last session, we ended with the types or forms of organic reagent, and this form of organic reagent we were described about the nucleophile, electrophile, and the free radical. But for today, we're going to look about the thing that we call nucleophile as the first form of organic reagent. We say that this nucleophile, this is the Greek word. So when we say this word, it means that this is the Greek word. We say that it's the word comes from two Greek words. Nucleus is come from two words, that is nucleus and pheros. And this word pheros, it means rough. So by definition, we can define as nucleus loving. So until the end, we're going to conclude that this is the nuclear loving. So when we say nucleophile, we say the nucleophile, the nucleus loving. In part of nuclear loving, in some essence, in part of first base and salt, we can say that this is the Lewis base. Why it's the Lewis base? Since it has a bit of donating its electrons, maybe the lone pair or the free electrons, or from the double bond. So those we call Lewis base or nucleophile or nucleus loving. So when we describe about the electrophile, we try to look at those atoms, molecules with free electrons that have a bit of sharing with another atom to make it is a new bond formation. So by definition, we can say that this is the nuclear loving, or for some time we can define as it's the form of organic reagent containing is the form of organic reagent containing an atom with unshared or lone pair of electrons which can be shared with another atoms to form a new bonds. So this is what we call a nucleophile. So this is the form of organic reagent containing an atom with unshared or lone pair of electrons which can be shared with other atoms to form a new bond. So for that, when we look about this aspect of a nucleophile, as I said previously, this is the nucleus loving. So this we try to look for those Lewis bases, and when we say Lewis bases, we can categorize them into three forms. So make sure that you have a bit of describing that, since it is more crucial during the reaction mechanisms when we start to the specific area. So until now, we're going to look at these categories of nucleophile. Nucleophile, it is categorized into three forms. So it is categorized into three forms. Yeah, it's categorized into three forms. So when we say nucleophile, we try to look about three aspects. The first thing is about the negatively charged atom. This negatively charged atom, we try to look at those with a higher electronegativity. it means that I have a bit of attracting electrons toward itself. So it means that I have higher electronegativity. And also we try to look for those elements that are a non-metallic element or non-metal element that is mostly appeared to the right hand side of your periodic table. It means that the trend of electronegativity increases through the right hand side of your periodic table. So from that now, it means that we can look an example for those elements. For some of them that is most common, we can look about the chlorine. Also we can look about the bromine. Also we can look about the fluorine. Also we can look about the oxygen and several forth, but this one is the most that we use during the organic reactions. But there are several forth that is basically shown like this way. But for the second aspect, we can look about for the second aspect we look about the negatively electrophile nucleophile, not the electrophile. This neutral electrophile, we try to look at those with the lone pair. About what? Lone pair. So this is what we call neutral electrophile. It means that I have a free electrons that is seen to be free from the atom or a molecule. So it means that this we can take an example like in ammonia. This has lone pair like this way. This one has lone pair like this way. Also we have water. Also has lone pair like this way. Also we have another things like alcohol. Have lone pair like this way. Also we can have an amide. Amide, which have lone pair like this way. So it means that when we say about this nucleophile, we try to look about the negatively charged atom as said previously from the part of electronegativity of an atom, and the most is common for the non-metallic element. And also we can look to the second one, that is neutral nucleophiles, and this neutral nucleophiles we're going to look about for those with lone pair like amine, water, alcohol, and sulfur. It means that we will look all the atoms that have neutral electrophile or have lone pair. It means that we're going to look about the nucleophile, specifically in neutral nucleophile. And the third one, the third category, we can look about for those with multiple bond. The third one is about for those with multiple bond. Third one, we will try to look about multiple bond nucleophile. Multiple bonds nucleophile. And this multiple bond nucleophile, we try to look about alkane, and iron. For those in part of alkane, we try to look about the double bond, and also here we can look about the alkyne, that is triple bond, and also we can look about alene, that is maybe a benzene. So this is what we call multiple bond nucleophile. So it means that when we look about the aspect of nucleophile, we try to describe three things: negatively charged, multiple bond, and the ones with unpaired electrons, that is about their own pair. So in part of the multiple bond, on what we say this, it can be a free electrons due to the certain conditions. When maybe a certain atom is come to substitute its bond, it means that the carbon have 4 bonds, but it means that when this bond, maybe here there is chlorine and here there is maybe a fluorine, or maybe there is a hydrogen. So it means that there is a certain species that makes the reaction to be tended to occur here, so it may be substituted with this one. So it means that when you come closer with this one, it means here it will be form 5 bonds, that is the carbon can't exist in 5 bonds. So until the end, it means that this one it will break. So the breakage of this one, it will stimulated by this hand, that it will cause this bond to break to the other side, and this form positive and this form what, negatively charged ions, due to the free or due to the electrons to move in a total. It means that there is a heterotic bond cleavage and a homolytic. So this is a hetero bond cleavage. It means that the breakage of electrons, it is not equal, so it be different. It means that there is loss and gain of what, of electrons. So until the end, this one it will cause the reaction or a certain reaction to tend to occur. So from that, this is what we call nucleophile. So I know for the another session or for the coming sessions, we will continue with the electrophile, and the last one we will finish with the free radical, that is in shorter forms, but this one is the common ones that is seem to be longer than those. So it means that the coming sessions I will continue with this too, and I will finish. So make sure that you pretend on that you know in reality case.